Well, we've made it to the end of the semester. One last major task to do, and that's to complete the final examination. So this video is going to walk through the exam and show you the things you need to know to successfully complete the course. Remember, our exam is at 8 a.m. on Monday, December 16th. We meet in our normal classroom in the Art Sociology building, room 2309. If the university's open, if there's no weather problems, I'll be there and so will the TAs. So please don't be late for the exam and leave plenty of travel time. It's early in the morning and the weather can be bad, but if the university's open, we're all going to be there to give you the exam. Let's go ahead and look at the overview. This exam is going to have 8 questions. We're going to start with confidence intervals. We'll do a difference of means t-test. We'll have a contingency table or cross-tabulation problem. We'll look at odds ratios, analysis of variance, correlation, and regression. You can see the relative points over on the right-hand side of the slide. I'm going to go through each one of these questions one at a time to show you the material that's going to be on the exam. The one thing about this exam that will be a little bit different than the first 2 exams is there's very little hand calculations. Yes, you'll need a calculator, particularly for the odds and the odds ratios, but mostly we'll give you computer output and ask you to do hypothesis tests and to interpret the findings. Let's go ahead and look at the first question. We're going to give you some output that looks roughly like this. In the upper left, what we're giving you are 2 means and their confidence intervals. We can see that we have, for the problems worked through in this sample exam, we're going to look at a dependent variable, which is occupational prestige, which is a continuous variable. I've broken out 2 different classes, people who are in the lower class and people in the upper class. We've calculated their average occupational prestige, 36.42 and 49.83 respectively, and calculated confidence intervals. On the right hand side is a graphic that shows you what those confidence intervals look like next to each other. You're going to be asked to take one of those confidence intervals and to interpret it and provide an explanation of what a confidence interval is for somebody who hasn't taken a statistics class. So think of this as describing it to your roommate who maybe hasn't taken statistics, or to your parent. Based on that graphic, we're going to have you look at it and try to determine if you think there's a statistically significant difference in those means. In this particular graphic, it appears to me that there is, because the confidence intervals don't overlap. And then we're going to ask you to describe why those confidence intervals are different sizes, why the lower class interval provides a much more precise estimate of that mean compared to the upper class interval. That's it for question number 1. As you can see, there is no calculations in this particular question. Question number 2 is a difference of means t-test. So this is based on problem number 1. Again, we've got the 2 average occupational prestige scores for people who are lower class and people who are upper class. The numbers are 36.4 and 49.8 for lower class and upper class occupational prestige. In the computer output, you can see that the difference between them is approximately 13.4. It's that difference which is what we're testing with our difference of means t-test. We have 2 ways of doing this. We can go straight to the p-value at the bottom of the table in the middle. That's the 2-tailed test. The other tests on the left and the right are 1-tailed tests, but we're not going to use 1-tailed tests for this exam. We could also look at the calculated t-statistic in the table, which in this case is minus 6.37, and with the appropriate degrees of freedom, 192, go to the t-table and look up t-critical. So this question is going to ask you to look at computer output like this and do a hypothesis test of the difference of 2 means. Again, there's no calculations required for this. Simply use the numbers in the output to walk through the hypothesis testing procedures and then interpret your findings. Question number 3 is a contingency table or cross-tabulation question. We're going to give you output that looks very similar to this. On the left-hand side is a cross-tabulation table where we've appropriately laid the table out so we could calculate gamma, so that our table, our values that go from low to high, from bottom to top, and from left to right. And we've calculated the percentages correctly based on column marginals. So we can compare across our independent variable, that is subjective class identification and compare across the columns. This particular output shows us the relationship between how people view their social class, lower, working, middle, and upper, our independent variable, and how satisfied they are with their job, or if they don't have a job, with doing housework. On the right-hand side is a graphic. In each row, we have a column, a bar, where the height is equal to the percentage from the table. So we can see, if we look right across the very satisfied row, we can see that as people go from the lower to working to the middle to upper classes, their job satisfaction increases. It goes from 33.9 to 46.4 to 53.7 to 61.9. We can see at the bottom of the table, for example, the third row from the top, where people are a little dissatisfied with their job or housework, that this, as we go from lower to upper class, satisfaction decreases. We're going to ask you to use hypothesis testing techniques to determine if these two measures are statistically independent of each other. You don't have to calculate chi-square here. It's given in the table. We'll provide you the chi-square. In this example, chi-square is approximately 34.9, and then we have our p-value right next to that, and we can see that it is statistically significant, alpha 0.05. And we know that because the p-value to 3 decimal places is 0. We're going to ask you to describe the relationship between these two measures and to interpret gamma. Again, gamma is given to you in our output. In this case, it's minus 19.39. I think we can safely ignore the direction and basically indicate that, number one, we would reject the null hypothesis. So there's our test of significance. We can talk about the direction of the relationship. As people move to upper classes, we tend to see an increase in job satisfaction. Alternatively, as we go from lower class to upper class, we see a decrease in people who are very dissatisfied. The relationship is a weak or moderate relationship, using the table in the book and my amendment to that table. And the gamma statistic, which ranges from -1 to 1, is minus 0.19, and so that's where we're getting this notion that it's moderately strong. So again, we're going to discuss statistical significance, direction, and importance. Now, for the importance of this variable, this is actually a pretty strong relationship by just looking at the percentages. Look at the very satisfied row. If we compare lower to working, we see over an 11 percentage point difference. If we then move from working to middle, we again see about an 8 or 9 percentage point difference. And if we go from middle class to upper class, we go from 54 approximately to 62, another large increase. So there's a pretty substantial increase in the percentage of people who are very satisfied as we move from lower to working to middle to upper class. That's the substantive importance. Question number 4. We're going to give you a univariate frequency distribution and ask you to calculate and interpret odds of some event. In this case, I'm looking at outcomes of the presidential election, or who people voted for in 2008. We can see we have 809 people who voted for Barack Obama and 498 who voted for John McCain. Converting those frequencies to percentages allows us to calculate the odds. Remember that odds are always the ratio of a probability of some event, in this case voting for Obama, over or divided by the probability of not voting for Obama or not that event. Let's go ahead and see what that looks like. Taking the numbers right off the table, we can see that the proportion or probability of voting for Obama among our respondents is 0.619. Therefore, the probability of not voting for Obama or voting for McCain is 0.381, and the ratio of those two values is 1.62, giving us an odds of voting for Obama of 1.62 to 1. And that tells us for approximately every 2.6 people or 2.5 people, 1.6 of them voted for Obama. 1-to-1 odds is chance, 50-50. Anything greater than 1 implies greater than average chance, and anything less than 1-to-1 is less than average chance of that event occurring. Question 5 is related to question number 4. And this is asking you to calculate and interpret an odds ratio. Now, Question 4, we couldn't calculate an odds ratio because we only had one odds, that is the overall odds of voting for Barack Obama. But now I've taken this notion of whether you voted for Obama or McCain and divided it up across our lower and upper class groups. We can now compare across our independent variable the odds ratio of lower class to upper class voting for Obama. Let's see how those numbers work. We're going to have to calculate two separate odds. The odds of lower class respondents voting for Obama, which is 0.85 divided by 0.15, or approximately 5.67 to 1. Then we need to calculate the odds of upper class respondents voting for Barack Obama, and that's 0.6429 divided by 0.3571, or approximately 1.8 to 1. You can see when looking at those two odds that lower class respondents were a lot more likely to vote for Obama than they were for McCain. How do we compare those two numbers and put them into a metric that's understandable? We take the ratio of the odds of lower class voting for Obama to the odds of upper class voting for Obama, 5.67 divided by 1.81, and get an odds ratio of 3.15. And what that number tells us is that when we compare lower class to upper class, people in the lower class, the odds of them voting for Obama were over 3 times greater than people in the upper class. It's a nice metric to help us understand the table. And of course, we would also like to provide a chi-square for this table and possibly even a measure of association like Ewell's Q. But for this problem, we're simply going to have you calculate and interpret the odds ratio. Question number 6 is an ANOVA problem. We're going to give you output very similar to this. We'll give you a table of mean, standard deviations, and sample sizes. Those groups, in this case I'm using subjective social class, lower, working, middle, and upper, that's our independent variable. The dependent variable in this case is still occupational prestige. Of course, the variables we use on the exam will be different than these. We're then going to give you an ANOVA table, so you don't have to calculate the sums of squares or complete the cells in this table. We're going to ask you to do a hypothesis test to see if there's a difference in means across these categories, in this case the working class categories. We can see that the lower class has an occupational prestige of 36.42, the working class of 40.52, and so forth. The question is, are those observed differences in means statistically significant? Like the difference of means t-test, we have two ways of answering this question. We go right to our ANOVA table and we can look up our F statistic, which in this case is 61.50, and use the appropriate degrees of freedom, 3 and 1,872, and use the F table in the back of the book, or any F table, to determine what F critical is and compare it to this value. If the F calculated, the one in the table, exceeds F critical, then we reject the null hypothesis. Alternatively, we can look at our p-value, which in this case, accurate or precise to 4 decimal places, is 0, and make a decision to reject the null hypothesis. Since I've set up alpha here to be 0.05, we're definitely going to reject the null hypothesis, and then we have to worry about our interpretation. Our interpretation is going to discuss significance, so we're rejecting the null hypothesis with alpha 0.05 and concluding that the observed average occupational prestige values for lower, working, middle, and upper class are statistically significantly different from each other. We're going to talk about the direction of the relationship, and here we can see in the table at the top that as we go from lower to working to middle to upper class, average occupational prestige increases. And then we're going to talk about magnitude, and here again we would do something like we did in the cross tabulation table, and we can see that every time we increase from lower to working, working to middle, there's an approximate 6-point increase on that occupational prestige score. The only place we don't observe this is comparing middle to upper, where we see a 2-point difference, a much smaller difference. And so this is telling me that our biggest differences are lower, working, and middle, and then middle and upper are very similar to each other. In question number 7, we're going to give you Pearson's R-squared and tell you whether it's statistically significant or not. You won't have to calculate a test of significance for this particular Pearson's R-squared. We're going to give you the scatter plot, very similar to this one, and here we're looking at the relationship between the number of years of education, our independent variable, and the occupational prestige score. We're going to ask you to describe the relationship using Pearson's R and the scatter plot. So we want you to provide an interpretation of how these two measures are related to each other, and in particular you should discuss direction, magnitude, if the relationship appears to be linear or nonlinear, and if there are any outlying cases that might be influencing how that regression line is put through those points. Also discuss the test of significance. So here we go in this particular problem. We observe a correlation coefficient of about 0.5. That's a strong correlation coefficient, and it indicates a positive relationship between these two measures. By positive relationship, we mean that as education increases, we see an average increase in occupational prestige, and that's indicated by the regression line in the graphic extending from the lower left to the upper right. We can see that this relationship is relatively strong because the points are fairly tightly packed around the regression line. The relationship appears to be linear. That is, I don't see anything in how the points are plotted that would indicate that line should be bent a bit to better fit the points. It appears to be a monotonically increasing relationship. We reject the null hypothesis and conclude that this particular relationship is statistically significant. What we need to do next is calculate a regression model so that we can talk about exactly how much the average increase in occupational prestige is for each year of education. And we'll look at that in the next problem. In problem number 8, we're going to go ahead and calculate the regression coefficients for you and give you a table very similar to this one. This is remember when we talked about the 3 parts of the regression table, this is that third part that just has the coefficients. Where you see underscore CONS, that's beta hat sub 0, or A, or the intercept, or constant. Where you see EDUC is our education variable in this case, and the coefficient is 2.29. We're going to ask you to take the coefficients from this table and to put them into a regression model. Pretty simply, it's going to look like this. We see that a predicted value of occupational prestige is equal to 12.5, our intercept, plus 2.29 times number of years of education. And we can plug any value we want into the education part here, the education variable, and calculate a predicted value. We're going to ask you to interpret this slope coefficient, or the regression or slope coefficient, that is the 2.29. We're going to ignore the constant. Let's look at a graphic of this relationship. I've gone and plotted the fitted line, or the y hat line, and we know that delta y over delta x, for a 1 unit change in x, the regression coefficient says that there's an average 2.29 change in occupational prestige. For every additional year of education, on average, we observe an additional 2.29 units of occupational prestige, which is pretty good given that the occupational prestige measure ranges from 16 to about 76. To make this more visible on the graphic, I said, what if we increased x not by 1 unit, so delta x is not 1, what if we increased it by 5? Delta x equals 5. Then I would take 5 times 2.29. If a 1 unit change in x is associated with a 2.29 unit change in y, then a 5 unit change in x must be associated with a 5 times 2.29 unit change in occupational prestige, and it's 11.4. And so we get this kind of stair-step function. Every time we increase x by 5, we increase y by 11.45, or every time we increase x by 1, we increase y by 2.29. So our interpretation here is that there's a positive relationship between education and occupational prestige. For every 1 unit or every 1 year increase in education, there's approximately a 2.29 unit increase in occupational prestige, or if we look at it over 5 years of education, approximately 11.45 increase in occupational prestige. We're also going to calculate a predicted value for people with some value on our independent variable. For this example, I've said, well, let's calculate the average occupational prestige for people who have 12 years of education. And simply, we go back to our regression model and plug 12 in for education, 12.5 plus 2.29 times 12. We get a predicted value, or a y hat, an estimated value of occupational prestige of 39.9. Finally, we give you the coefficient of determination, which is our Pearson's R squared, at least in the bivariate case. We get a very low Pearson's R squared, 0.02, and we ask you to interpret that value. Of course, all the numbers will be different and the variables will be different on your exam, but the interpretation of this 0.02 goes something like this. There's a certain amount of variability among occupational prestige. Education is correlated with prestige and explains some of that variability. Out of the 100%, or out of the total amount of variability of occupational prestige, 0.02 of that is explained by, as a proportion, is explained by education. A very small amount. Pearson's R, when squared, ranges from 0 to 1. 0 for the coefficient of determination would imply no correlation, no relationship between these measures. 1 would imply that if we knew a value of education, we could make a perfect prediction about somebody's occupational prestige. Well, that's it. That's the exam in a nutshell. It's been great teaching the course this semester. Everybody's going to do well on the exam. I have a pretty good feeling about it. Again, please be on time, and as usual, if you have any questions, please contact me or the TAs and we'll do our best to answer them.